Okay, here we go with a continuation of the kind of the introductory presentation on stoichiometry. So the third question that I'm going to pose regarding this reaction is the following. How many moles of water can be produced from 17 moles of nitrogen monoxide if we have an unlimited supply of ammonia? Okay, so this time we have an excess of ammonia, so we don't have to worry about running out of this stuff, but the nitrogen monoxide is what we have a limited supply of. In fact, how much of this are we given? Well, 17 moles. Okay, and the question is, how much water can we produce from that reaction? Okay, so I think you can see that if you step back, what are the two coefficients that we need to zero in on here? So we're talking about nitrogen monoxide. We're being given a certain amount of that, and we're being asked how many moles of water can be produced. So if you said the 6 and the 6 for nitrogen monoxide and water, you're right. That is the mole ratio that is relevant to this question. And this is one of those questions that if you're thinking carefully about what's going on, I think you will realize that you can just basically put your pencil down, put your calculator back in the drawer, and you know the answer immediately, right? Because if there's a 6 to 6 molar ratio, that's basically a 1-to-1 ratio. So if you put, let's say we were solving a different problem and we were being asked, hey, I'm going to give you 1 mole of this nitrogen monoxide. How many moles of water? Well, I think you can see that since it's a 1-to-1 molar relationship, you'd get 1 mole of water out. Likewise, if we were given 6, you'd get 6 out. And in this case, we're being given 17 moles of nitrogen monoxide, so it's pretty straightforward. We should get 17 moles of water out of this. But I will set this up just like we will for less obvious problems, just for completeness. All right, so moles of water equals 17 moles of nitrogen monoxide. And then the molar ratio here, as we said, was 6 moles of water and 6 moles of nitrogen monoxide. And while we're talking about a problem that's fairly straightforward, notice that these numbers that appear in the mole ratio come directly from the problem. Okay, so I think so this 6 is from there, this 6 is from there. So you always look back at the balanced chemical equation when you're obtaining the numbers for the mole ratio fraction. Okay, so this is a good time to kind of reinforce that. All right, so and I think you can see that 6 over 6 is 1. 1 times 17 is still 17. The moles of nitrogen monoxide cancel out, leaving you with moles of water. And that is the answer to this question. Okay. Now, since we have a little bit of time left, let me change things up a little bit here. Let's see. I wonder if I can slide this over. Okay, I'm not sure how this is going to play out on the video, but I just slid the frame over so that you can see the website. So the homework assignment for Monday night, if everything goes as planned, is worksheet number 2. And let's back up a little bit. So this is what it looks like. And the first problem, I'll just kind of talk you through it. It says be sure to show all steps, all conversions, all units. So please Be sure to adhere to that, because when the first quiz comes around, and certainly on the test, you will be graded on showing your work, showing the conversion factors and units. So the first problem deals with this chemical reaction here. Gives you a little background, tells you that carbon disulfide is an industrial solvent, and here's the reaction. If you want to produce carbon disulfide, one thing you can do is you can react pure carbon, which is called coke in the industry, with sulfur dioxide gas, and you'll get carbon disulfide, the industrial solvent, plus, unfortunately, carbon monoxide. So obviously this reaction must be run in very carefully controlled circumstances. So you're being asked first, okay, how many moles of carbon disulfide could you form if you had 2.7 moles of carbon that you're putting into the reaction? Okay, so one little difference in this question is that it's not explicitly telling you whether or not you have an excess of sulfur dioxide. It's telling you you have 2.7 moles of carbon, okay, but it's not saying anything about whether you have a sufficient amount of sulfur dioxide. When it's not explicitly mentioned, you can assume that the other reactant is present in, excess. It's unlimited. Okay, so let's see here. You're being given 2.7 moles of carbon. You're being asked about carbon disulfide. So what's the mole ratio that you need to use here? And I think you can see that since you're talking about carbon and carbon disulfide, the relevant coefficients are the 5 on the carbon and the implicit 1 on the carbon disulfide. All right, so you'll take 2.7 moles of carbon, and you'll multiply that by the mole ratio between the carbon and the carbon disulfide. Which one will go on top? So think about that for a second. Which one of these two is going to go on the top of the mole ratio fraction? Well, you're being asked to solve for the moles of carbon disulfide, so you'll want to put 1 mole carbon disulfide on the top, 5 moles of carbon on the bottom. So you're essentially going to take 2.7 moles of carbon and multiply by 1/5. And again, if we keep our critical thinking caps on, I think you can see that makes perfect sense, because there is a 5-to-1 ratio. For every 5 moles of carbon, you're only going to get 1 mole of carbon disulfide out. So it all makes good sense. Okay, so I think I'm going to stop there, and we'll see you guys tomorrow. Thanks.